All right. Good morning, everyone. Good morning, everyone.
Good morning.
There we are. Excellent. I'm Neil Thompson. For those of you who don't know me, I'm the director of MIT FutureTech.
I'm Rob Seamans. I'm a professor from New York University's Stern School of Business.
And we're very pleased to welcome you today to our 4th annual conference on this one on how fast AI automation will happen. To start us off, we're going to just go through, first say a few words about who we are. So we've already introduced ourselves, but I would ask our other 3 organizers, Emanuele, Matthias, and Tess, to stand up and wave so that people can know who you are. Okay, and
I'll very briefly introduce myself. I'm a little bit of the outsider here, right? Not from MIT, but from the NYU Stern School of Business. So we were really pleased to be working with Neil and his fantastic team to help co-organize this conference. I direct something called Center for the Future of Management, and we have a lot of focus on, let's call it, the forces that are affecting managers, and that could be everything from globalization to AI to future of work. And so if you're interested in learning more, please just use whatever your favorite search engine is to look us up, and feel free to reach out and I can tell you more. We're really excited to be here and be part of this. Thanks.
Wonderful. Thank you, Rob. Okay. For the conference today, let me say we are recording. Only those sessions that the speakers approve are going to go up. But if you ask a question sort of during that session, you would be on the recording. We probably will not put up the Q&A at the end, so that you have some sense of that. Okay. Okay, so for those of you who don't know FutureTech, let me say a few words about us. So we are one of MIT's largest research groups. We have about 100 people at this point. Those are about half computer scientists and half economists. And so we try and bring together sort of technical work in both fields and say these can inform each other and say interesting things about the future of technology and the future of society and what that's going to mean. Because of that sort of dual nature, we're actually both in the Computer Science and AI lab. That is physically where we are, where our lab is, but we're also in the Sloan School of Management. And to give you a flavor of just some of the recent work we've done, so we did some work with David Otter, thinking about as jobs get automated, how do you think about what effect that's going to have on workers? Turns out that our sort of sense of, oh, things get automated is always bad for workers, bad for their wages and stuff like that, isn't right. And you can sort of think about that in terms of the expertise of the task that gets automated. We did some work on meek models, shall inherit the earth. This is this idea of we've been on this quest to get ever bigger models, but actually because algorithmic progress, which we'll talk about in a little bit, because algorithmic progress is so fast, it actually means that the sort of benefit we've been getting from them will likely be eclipsed by this improvement in algorithmic efficiency, and that means that very small models will become more capable. That obviously has big implications for the spread of AI and what that means in terms of capabilities diffusing, both for good and for bad. And then some recent work on computational advantage in quantum chemistry. So we have some longstanding work thinking about where quantum is going to benefit and trying to dig into some of the key ones. People often list the same 2 or 3 things when they say quantum computers are going to be incredibly revolutionary. And so we tried to actually dig in and say, like, well, in those areas, do we really see it or not? And the answer is, you see it a little bit, but not as much as people might think given the hype around it. This also sits within a larger set of tools that we are building for the community. I wanted to highlight those here for those of you who might be interested in this. So Algorithm Wiki is a long-standing work that we've done. I think it's at this point probably the most comprehensive database of algorithms and how they've developed in the world. And this is thinking about, okay, well, as these things develop, how good are they? How fast can you run them? Theoretically, how good could they get? How much memory will they use? All of these kind of questions. The second one is the quantum economic advantage calculator. This is because that idea of where quantum is going to matter turns out to matter based on a lot of assumptions. And so if you read the literature, one paper makes one conclusion and they have one set of assumptions. Another paper has a different conclusion and a different set of assumptions. You kind of don't know what's actually doing the work in those things. We build this calculator so you can easily check across these things and say, let's change the assumptions. Let's change the problem that we're looking at. How does that change when quantum will or won't often matter? The AI risk repository, this is some work that we've been doing really trying to catalog all the risks that are emerging from AI. This really sits very firmly in the management side of things because firms are trying to think about, well, what risks are sort of traditional risks, and you really just can kind of handle them the way you've done it traditionally. What of them are brand new risks right, that you actually have to think very differently about, and what are traditional risks but are just at a different scale than the stuff that we've normally dealt with, right? It might be fine to say, like, we're used to dealing with fraud, but it takes us an hour to deal with each case of fraud, and now you have 100,000 examples of fraud, and what do you do, right? Those kind of issues. And then lastly, one that is coming soon, right on the web, you'll only see this, but a number of people in this room working very hard to build a very comprehensive database of both CPUs, GPUs, FPGAs, and other chips to understand how these are developing over time. Okay, so that's a little bit about who we are. The conference today, we're going to have broadly 4 areas that we're going to talk about. So we're first going to talk about the drivers and consequences of AI progress, right? What's actually pushing us along this. Then we'll talk about the automation of science. This really matters because, even if AI helps us a little bit, if it pushes science really fast, that could actually make a really, really big difference for the economy and what we're able to do. We'll talk about the labor market as well tomorrow morning. And then at the last one, we'll come to this constraints to AI progress. Because of course there's a lot of hype out there, but the question is like, well, what might actually slow us down? That could matter a lot. All right, so we're going to start with a tradition that is very deeply embedded at the NBER, which is for everyone to introduce themselves. So we're going to go through the different rows. The thing I want to highlight here, your name, your institution. Notice I have in bold and underlined the one sentence about what you do. In previous conferences, the early speakers have done this, and by the time we get to the later speakers, they're giving us a couple of paragraphs. One sentence, okay? Christina, will you start us off?
You want me to? We're passing the mic. Hi, I'm Christina McElhern. I'm at the University of Toronto, and I study digitization adoption and productivity implications in firms.
Hi, I'm Yutaro Yamada. I'm a research scientist at Sakana AI, and I've been interested in LLM agents for like automated scientific discovery and self-improving AI.
Hi, I'm Larry Rudolph. I'm an old-time computer scientist. I'm actually not working now, but I was at MIT.
Good morning, Damian Sicotio. I'm with FutureTech. I lead partnerships for Neil and really love innovation.
Hi, my name is Patrick Rouge, a research scientist with IBM, and I work on AI for scientific discovery.
Good morning, I'm Martin Fleming, research scientist, economist, and research scientist here at the FutureTech Lab, and working on enterprise AI adoption.
Hey everyone, my name is Harry. I'm with FutureTech. So my background is AI and also working on the AI adoption for firm level.
Hi everyone, my name is Lucy Yen. I'm with MIT FutureTech operations team. Please follow us on LinkedIn, Twitter, and Substack.
Hello, I'm Matthias Mertens. I'm a research scientist at MIT FutureTech. I work on AI's effects on labor markets and firms.
Hi everyone, good morning. I'm Alex. I am a research assistant at MIT FutureTech, and I study how AI is being used in the scientific literature.
Good morning, I'm Sebastian. I'm a PhD student here at MIT and work with Neil in the topic of robotics and progress of robotics.
Hello, I'm Emanuele. I'm a research scientist at MIT FutureTech, and I study progress and trends in computer architectures.
Hi, good morning, everyone. My name is Mert Demirer, and I'm at MIT Sloan. I study productivity effects of AI on software development.
Hello, everyone. My name is Wanjay. I'm an RA at MIT FutureTech, and I studied the economics of AI innovation and growth.
Hey, I'm Nikhil Dilip. I'm a pre-doc at NYU Stern with Rob, studying firm-level AI adoption.
Good morning. I'm Joe. I'm at FutureTech. I study the production of science and innovation and the role of AI in that role.
Hello, my name is Seong Choi. I'm an assistant professor at SUNY Albany, and I'm working on the economics of AI and quantum computing.
Hi, I'm Daniel Lashkari. I'm an economist. I work also with the FutureTech on the economics of technology and AI.
Hello, I'm Stasha. I'm professor of informatics at Indiana University Bloomington, and I studied different topics within the area of science and innovation.
Hi, my name is Mason Sun. I am an assistant professor at the University of Illinois Urbana-Champaign School of Information Sciences and also an affiliate with the FutureTech. I study the geopolitics of AI and AI policy.
Hi, my name is Mandy Shen. I was a research fellow at Harvard Kennedy School. I study the economics of drug innovation.
Hi, I'm Yu Chen from NYU Economics. I study how the popularization of AI changes the type of research people pursue.
I'm Casimir Smith. I'm with FutureTech. I study economics of AI and markets for models.
Hello, I'm Brittany Harris with MIT FutureTech, and I'm a survey statistician that focuses on research questions that can be answerable with survey methods.
Hello, my name is Anna Trišević, and I'm a research scientist here at FutureTech, and I study how AI is used in science using AI.
Hi, I'm Zachary Brown. I'm at FutureTech with Neil, and I study the economics of AI.
Hello, my name is Jeffrey Lee. I'm a research assistant at MIT FutureTech, and I broadly study the progress of algorithms.
Hello, everyone. I'm Jonathan Rosenfeld at FutureTech, and I'm interested in the fundamental limits of AI performance and controllability, how it behaves.
Hey everyone, I'm Adam Kuzay. I'm a research assistant at MIT FutureTech. I assist with researching performance of LLMs on tasks in the economy.
Hello, I'm Dev, instructor at University of Toronto, and I am on a special task force with Canada Pension Plan and the Government of Canada talking about AI in the global investment space.
Hi everyone, I'm Aaron Kay. I'm an assistant professor at Boston University in the Questrom School of Business. I study digital platforms and the economics of AI.
Hi, I'm Will Fowler. I'm an undergraduate at Tufts University. I'm currently studying AI risk and tracking AI incidents.
Hi everyone, I'm Benedikt Wiese. I'm a visiting researcher at Harvard Business School, and I'm working on the impact of AI on platform business models.
Hi, I'm Philip Trammell, an econ postdoc at the Digital Economy Lab at Stanford, and I study theory of economic growth and how automation, especially from AI, could affect long-run growth.
Hi, I'm Andrew Lone. I'm at Georgetown Center for Security and Emerging Technology and temporarily here at FutureTech studying cyber and AI policy.
Hi, I'm Omid Maxion. I'm a postdoc at FutureTech, and I study macroeconomics and labor markets.
Hi everyone, so my name is Ziao, so I'm a PhD candidate from Northeastern University, so I study on how AI adoption affects firm-level productivity.
Hi everyone, my name is Kevin Saldaña. I'm a master's student here at MIT doing a master in engineering and management, and I'm interested in researching in the intersection of AI and economics.
Hi everyone, I'm Jane. I'm an assistant professor in economics in University of Illinois Urbana-Champaign. I'm also affiliated with FutureTech. I study AI in science, macro labor, and economic growth.
Hi everyone, I'm Feng Yuan, also from the University of Illinois Champaign, Urbana, and from the Department of Computer Science. I'm an assistant professor, upcoming one, and I'm researching in the AI tools and automations for non-computer scientists. Thank you.
Hi, I'm Jim Besson. I'm the Executive Director of the Technology and Policy Research Initiative at Boston University. We study the impact of technology on society, the workplace, and markets.
Hi, I'm Ken Flam. I'm an economist working on various projects here at FutureTech and a professor emeritus at UT Austin.
Hi, I'm Hans. I'm at FutureTech, and I study technical advances in AI.
Hi, everyone. I'm Rebecca Newcomb. I work at Dell Technologies in corporate strategy and primarily focusing right now on looking at AI skilling and upskilling within our organization as well as outside of our organization.
Good morning, Natalie Gully, also with Dell Technologies Corporate Strategy, and like Rebecca, focusing on AI skilling and how we upskill the workforce to be ready for AI.
Hello, I'm Nicola Meluso, assistant professor at Lewis University of Rome. I'm visiting MIT Sloan, and I study economics of science.
Hi, my name is Wei Liang Tan. I'm a postdoc at the MBER, and I study the geography of innovation and entrepreneurship.
Hi, my name is Myra Monin. I'm an economist at the University of Ottawa, but visiting MIT Sloan, and I work on innovation and AI, the role of AI in scientific discovery.
Hello, I'm Luke Yuan. I work in MIT FutureTech. My work involves in understanding AI adoption through large representative survey data.
Hi everyone, my name is Yang. I'm a postdoc at MIT FutureTech. I work on the economics of innovation and firm-level AI adoption.
Hi, I'm Tamara Broderick. I'm an associate professor here at MIT Electrical Engineering and Computer Science, and I study evaluation, uncertainty, and robustness.
Hi, I'm Claudio. I'm a postdoc at Harvard, and I develop methods for trustworthy AI.
Morning, I'm Gabriel. I'm a PhD student at FutureTech, and I study the economics of AI and the adoption in science.
Hi, everyone. I'm Lucy Hampton at MIT FutureTech, and I study the labor market impacts of AI.
Hello, everyone. I'm Tess Fagan. I lead operations at MIT FutureTech, and I hope you enjoy this conference.
Hello everyone, my name is Shohei Minamiguchi. I'm from Mitsubishi Corporation Americas Boston branch. We are responsible for the tech and startup scouting in Boston. Nice to meet you.
Hi, my name is Asher Lasday. I'm a PhD student at NYU Stern in the management department. I study firms' political behavior and sort of starting to think about that more, especially in the context of innovation and science.
Hi, I'm Paul LaForge. I'm a dean in the School of Technology at Western Governors University, and I'm studying AI's impact on the labor market.
Hi, Kyle Gracie. I work for an international nonprofit called think tank called Future Matters, and we study the political economy of society's reaction to AI.
I'm Jason Lynch. I'm a theoretical computer scientist with MIT FutureTech, and I study how quickly algorithms have been improving over time.
Hi, I'm Phileas. I'm a software developer at Wolfram Research, and I spend my days working on network science applications of like for ecology and that kind of thing.
Hey, I'm Scott. I'm a postdoc at Ohio State University, and I study LLM behavior with focus on things like theory of mind and model personality.
Okay, wonderful. And thank you all for being so diligent about the one sentence. Okay, so to set us up for our first set of sessions, I want to start us out with saying, okay, if we ask this question about how fast AI automation will happen, a clear part of that is about the capabilities that AI is going to have. And here there are some very strong assumptions. So, the CEO of Anthropic, Dario, has said, oh, we could have AGI next year, right? System capable of basically all of the tasks that we can do, at least in a sort of virtual way. That would be incredibly transformative. A report that got a huge amount of attention, the AI 2027 report, says that we're on this path, but their current prediction is that we might get artificial superintelligence in 2028. And some recent work coming out of Meter by Quan West says that as time goes on, we're getting these systems that are capable of doing longer and longer time window events. And if you actually just do the calculation, that means that we expect systems that are 50% capable, meaning 50% of the time they would get the right answer, on tasks that take humans a full month by 2029. Okay? So these are sort of very, very strong senses of like maybe these capabilities could expand a lot, right? Now, some of these, I would argue, like the underlying thing is not taking into account all the bottlenecks you might imagine for science and things like that. But nevertheless, these, there are definitely predictions that this stuff could happen pretty quickly. Okay, so that's capabilities. But if we actually ask about adoption, and we will hear a lot more about that in a second, if you look at things like the census data on this, right, you see that, about 8–9% of firms are using AI in sort of meaningful way, they are indeed, within the next 6 months, they're planning to get up to maybe like 13% or something like that. But that's not, this is not like everybody's doing it for everything. This is like people are moving in more gradually. And in some of the work that we've done, we've asked the question, well, in this case, this is for computer vision. If you ask for all of the tasks that humans are doing, even if you were to get really, really rapid improvements in the systems that we're building, so a 10% annual cost decrease, 20%, 50%, and that's everything. That's all of the deployment costs that you would have for that. Even with such a thing, the share of compensation that you would actually automate, can still take decades in order for stuff to actually be adopted. So we have this sort of interesting thing, right? We have these predictions of incredibly rapid capability development and observations that adoption is moving, and by historical standards is fast, but nowhere near the whole economy side of thing, right? And that even with rapid progress, there might be lots of tasks that don't get automated that quickly. And so, I think you can think of this as sort of a very simple model where you think, okay, well, as AI capabilities develop, you would hope that that would lead to more AI adoption. More AI adoption should lead to economic gains, and then those economic gains can sort of be invested right back into AI capabilities, because of course these models are getting very expensive. But all of these places have possibilities of things going, like breaking the cycle or at least slowing it down, right? You can have these really rapid capabilities, like the predictions are, but actually, if there are a lot of frictions and lags in adoption, right, it could actually be that it takes a long time for organizations to adopt in a good way. Even if you have adoption of some tasks, you could easily get bottlenecks and organizational adaptation issues that mean that there are just not that big of the gains that come to the firms that are actually doing that. That could limit what we get there. And for economic gains going to AI capabilities, this has sharply escalating costs, right? So all of these things have this potential to sort of slow down the system as we go. And so we'll hear about some of these today, but we'll also hear about sort of the idea of, well, some things might break this cycle, right? So you could imagine a situation where maybe we don't need huge economic gains to get escalating AI capabilities. Maybe we build a better AI model, and that feeds itself into producing a better model, right? And that means that we don't actually need a ton of adoption to do that. So these are some of the things that we're going to be exploring today. And so with that, let us turn in, and I will let me take two more seconds. Sorry. Okay, so we can ask this question: well, where has AI improvement actually come from? And I think here it's important to say, for those who are in this thing, you may have heard of this, but broadly there are sort of three things that happen, right? So you can have more chips running longer. For those of you who know the scaling laws, right, this is really sort of the dominant path people have followed. It said we can continue to scale up these models. You can have more efficient AI algorithms, right? And I've sort of drawn that as at a circuitous path, and you find a clear way to do it. And you can have more efficient GPUs that you're able to run on these things. And so in a bunch of the work that we've done, both ourselves and with Epoch AI, you can generate a chart that looks like this about progress in LLMs. So what we're doing here is we're normalizing to 2014, and we're asking, okay, how much hardware efficiency, hardware increase in quantity, and algorithmic efficiency have we gotten since then, right? And so the first order thing is to say, notice the top of this line is about a trillion-fold increase, right? So that would say, if we hadn't had any progress, right, we would have had to increase the amount of computation we're doing almost a trillion-fold in order to get the kind of improvement that we've gotten. So this is just sort of following the scaling laws. But we've had a huge amount of algorithmic efficiency improvement. So that means that we've actually only had to increase the amount of flops according to the green line here. And then of that total increase, 45x has come from actually these chips becoming more efficient, right? And so we actually didn't have to pay much for that, right? But we still had to pay a lot for this. Okay, so when we think about that cycle that I was just showing you, this is sort of saying those rapidly escalating costs, right? This is those rapidly escalating costs, right? And what's nice is if you have this or you have the algorithmic efficiency, that is not increasing the cost, right? If those are the dominant things, that's good. If this is the dominant thing, then you have rapidly escalating costs. And so far, that has been the dominant thing that has produced these benefits. Okay, so with that, I will turn this over to Matthias, who's going to do the introduction of our first speaker.